Right, lesson 4.9 we're going to do in 2 parts also. First of all, 4.9 is sort of a review of 4.4, where we did transformations, translations, reflections, and rotations, but we're taking them all a step further. So a little bit of a review. A transformation is an operation that moves or changes a geometric figure in some way to produce a new figure. The new figure is called the image. Okay? Translation moves every point of a figure the same distance in the same direction. Reflection uses a line of reflection to create a mirror image of the original figure, and a rotation turns a fixture about a fixed point called the center of rotation. First, we're going to do identifying. Name the type of transformation demonstrated in each picture. Okay, first we have a reflection in a horizontal line. Second, we have a rotation about a point P. And C, a translation in a straight path. Yep, we've done this before. You try. Name the type of transformation shown. Yeah, it's a reflection of the zebras in the water. Sort of a horizontal reflection. Okay? Wow. All right, let's talk about congruence. Translations, reflections, and rotations are 3 types of congruent transformations. First of all, we're going to do the translations. So, a congruence transformation changes the position of a figure without changing its size or shape. Translations. In a coordinate plane, a translation moves an object a given distance right or left and up or down. You can use coordinate notation to describe a translation. The coordinate notation for a translation is as shown. So, if we just pretend we have a point at, say this is at point 2, 3, we could use coordinate notation. If our original is 2, 3, we could say if I move this to negative 1, 2, 3, 4, negative 1, we just did x, y goes to, now 2 to negative 4 is x minus 6. Y, to get from 3 to negative 1, we'd have to subtract 4. That is our coordinate notation. So, beginning to end, we went from xy to x minus 6 and y minus 4. It shows that each point, which is xy, of one figure is translated horizontally a units and vertically b units. Example, figure ABCD has those vertices. Sketch ABCD and its image after the translation x plus 5, x minus 2. Now I've already sketched ABC in there for you, so let's just do x plus 5, negative 4 plus 5 is 1, and y minus 2. 3 minus 2 is 1. So I'm going to sketch that point. Negative 2 plus 5 is 3. 4 minus 2 is 2. So we get 1, 2, 3, 1, 2. Negative 1 plus 5 is 4. 1 minus 2 is negative 1. 1, 2, 3, 4, negative 1. That's a D. Oh, wait a minute. Nope, that's definitely C. And negative 3 plus 5 is 2. 1 minus 2 is negative 1. So 2, negative 1. That's D. Right, so here we just have the translation, and we used coordinate notation to do it. Okay, reflections. When a reflection is shown in a coordinate plane, the line of reflection is always the x-axis or the y-axis. A reflection in the x-axis, we would multiply the y-coordinate of your ordered pair by negative 1. So if you look, I drew the blue one first, and all of the points are xy. and then I flip it over the x-axis, my red one is x negative y. So in coordinate notation, we switch our xy ordered pair into x negative y ordered pair. A reflection in the y-axis, we multiply the x-coordinate by -1. So if I start out with blue, xy, and I flip it or reflect it over the y-axis, I get negative xy. So our coordinate notation goes from xy to negative xy. Example 3. You are drawing a pattern for a wooden sign. Use a reflection in the x-axis to draw the other half of the pattern. Pretty simple. Go down 2, over, down 2 more, and then meet right there. And if we were just to discuss, our xy would go to x negative y. You try. The vertices of triangle ABC are 1, 2, 0, 0, and 4, 0. A translation of ABC results in the image DEF with those vertices. Describe the translation in words and in coordinate notation. I actually think that I can get rid of this. Okay? We're going to try to do this without a graph. So I'm going to push pause and we'll go ahead and try them. All I did was wrote out each ordered pair, and then I noticed the pattern. I went from 1 to 2, which is x plus 1, 0 to 1, 4 to 5, x plus 1. And then I went from 2 to 1, 0 to -1, 0 to -1. So I did y minus 1. So our translation was write 1, down 1. You could also say add 1 to each x coordinate and subtract 1 from each y coordinate, but this is really important. You try another one. The endpoints of RS are R, 4, 5, and S, 1, -3. A reflection of RS results in the image TU with the coordinates 4, -5, and 1, 3. Tell which axis RS was reflected in and write the coordinate rule for the reflection. I'm actually going to delete this grid again because we don't need it. But go ahead and try it. I'm going to push pause. There we go. I just listed out the ordered pair so I could see the pattern. I wrote down the pattern, which is a reflection over the x-axis. Okay, that's all we're doing for today. We'll start here tomorrow. Good job.